Okay, this is a reshoot of the missing video that is after the bilateral monopoly up to A-Rod. So we're looking at basically work stoppages, strikes, and the probability of a strike. And let's recall that in the last video we were looking at the example of, say, A-Rod, and we saw how much he would actually be earning. It might not actually make sense for him to be engaged in any of the collective bargaining. I mean, why would he be? He's earning so much money, right? We also saw that it can be expecting of union leadership to actually produce a concentrated level of benefits, right, essentially to the elite members of the union relative to all of the members of the union. And they can do this because the costs of the benefits are spread out among all of the members, but the benefits from being a member are kind of dispersed with these costs, right? So we have this difference in the terms of the concentration of the benefits versus the costs of the union membership, where the cost of union membership are spread among everybody, but these costs, or the benefits, actually can be very, very concentrated. Now, you'll recall a couple of videos ago we were looking at player pay, and we had the example of the monopsonist. And just to review, we had our bilateral monopoly situation here now. Right, where we have a monopoly union and they are confronting a monopsony employer. Okay. And what we saw here, of course, was that this wage level kind of tends to be indeterminate, right? So let's kind of review that briefly here. So we saw that we would have, say, our quantity of labor. We would have, say, our wages, right? And we've got some demand curve. Right, here's our marginal revenue product, and you can have some basically marginal revenue here from our monopsonist. And we've got our supply of labor, right? And then, of course, we had this marginal expenditure. Okay. So we had something that kind of looked like this. And you'll recall that what we said was that under conditions of basically we would have kind of a situation here where I'm going to have this come down over to here. We've got some kind of, say, LM, right? Here is, in essence, the level that our monopsonist wants to hire at, and they want to hire LM workers, right? And they would like to pay a wage of, say, WM, right? Our union, though, wants to set wages where the marginal revenue of union workers is basically equal to the supply, and that is going to be right here. We'll call this guy LU, right? And of course, that would mean a wage rate all the way up here of, say, WU, right? So in essence, what we see here is we see that the monopsonist wants to pay some wage WM, whereas the union wants some wage, say, WU. And what we can see here is that we know that the wage is going to be somewhere between WM and WU. We just don't know where. We know that the amount of workers is going to be somewhere between LU and LM. We just don't know where. It kind of depends upon who has the relative strength in the bargaining situation. Is it the employer or is it the employees? Okay? So we can kind of illustrate what's going to happen here in terms of strikes by looking at people's wants, right? And so we have our conditions here where we've got, say, here would be an example of these are high wages over here, and these are going to be acceptable to our players. And then maybe we have some conditions here, right, where we've got low wages. And of course, these are going to be acceptable to the owners, right? And in essence, what we have here is we kind of have this, in this continuum right here, we have our little contract zone, right? Because there's some level of wages that are acceptable to the players, and there's some level of wages that are acceptable to the owners. And of course, you can have different situations, right? You can have, say, a powerful league. And with our powerful league, we could have a situation where in our contract zone here, you've got something that kind of looks like this. Here was our high wages. And here are our low wages, right? And once again, these are acceptable to the players. This is acceptable to the league. And we have some situation here that kind of looks like this, right? So in essence here is our contract zone. Right? And you can see that this kind of lines up roughly with this guy right here, kind of something like this, where we can say, okay, with the powerful league, they're more likely to draw that contract zone down to the lower end, right? Or you could have essentially the exact opposite. You could have a situation where you've got, here's our high wages. And here is our something that kind of looks like this. Here's our low wages. Here's our powerful union. We have our contract zone in here. Right? So if they're both kind of equally powerful, you kind of have something, kind of a zone that kind of looks like this. If you have a relatively powerful league, you kind of tend to be more in the lower end of this acceptable amount. If you have a powerful union, you tend to be more in the upper end of this band, right? And of course, you have the smaller amount of money in the contract zone with both the powerful league and the powerful union. Okay? Now, one of the problems, of course, is that you actually have misperceptions, and this happens all the time, where you have the amount that is actually acceptable to players. Once again, here's our high wages over here. You have the amount that is thought to be acceptable. And then you have the amount for the owners. Here's our low wages over here. Here's our owners, right? So if you think about this, in essence, they think that the actual contract zone is this size right here, right? This guy right here is what is believed to be, we'll do this guy and see. Yellow's not good. Let's do him and say blue here. Here's the amount that we believe to be the contract zone. So we're going to call this guy the perceived contract zone. When in fact, we see that the actual contract zone is this guy right here. Now, of course, this can cause all kinds of problems because the owners could be offering something in the perceived contract zone that is not in the actual contract zone, and they could believe, honestly, that they're negotiating in good faith when the problem is that they've actually misperceived what the players are actually willing to do. And of course, you could have the exact same thing happening vice versa. You could have a situation where the actual contract zone is much smaller than the perceived contract zone, except that this portion is over here. And so the players could say, here's what we think is actually acceptable to the owners, and it's not actually acceptable to the owners. Okay? So what we have here is when we have this, we can have a situation where if we're trying to negotiate in this component right here, people can believe that they're trying to negotiate in good faith when they're actually not. And of course, this can lead to problems. So we can have players strike, right? Where they're withholding, excuse me, they're withholding their services, or we can have our owners engage in a lockout, right? Where they refuse to allow them to play. And like I said, I mean, we can have these lockouts and we can have these strikes even when both teams are negotiating in, quote, good faith, right? It's just that they have a misperception as to what is the actual size of the contract zone, okay? So in essence, what you have here is you have this problem of asymmetric information. And this problem with asymmetric information is where one side has more information than the other side. And this can be especially problematic when one side uses strategic misrepresentation to make the other side think that they're in a stronger position than they really are. Okay? So we can see here that it actually might be profitable to have a strike or a lockout, right? And let's look at some ways that that might be possible. So let's index our time here during the strike or lockout to T. So we can have T0, 1, 2, 3, etc., all the way up to S. Okay? And we can have time after the strike or lockout. We're going to call that guy T. And that's going to be S plus 1, S plus 2, S plus 3, all the way up to big T, right? So here's our strike lockout time. Here's after strike. Okay. Now we have several different things that we can look at here. One is we're going to call this guy A. We're going to call this guy the alternative values. Open to our decision maker. So our owners can do a couple different things. They can rent out the stadium to, say, concerts or conventions. They can also make use of scabs, so they can have other people come in who are not part of the union and play. Our players, they also have alternatives. All right? They can essentially make more guest appearances. Okay. And if we look at this, we can tally up A as being equal to the summation. T equals 0 to S of AT, 1 plus R to the T, right? Where in essence, we're looking basically at the present value of the stream of income that we can get from these alternatives. Okay. We have the income that was lost due to the work stoppage. We're going to call that guy M. Okay. So for our owners, this will be lost game revenue. For our players, it's lost pay. Okay, and once again here, our M, the summation, T equals 0 to S, MT, over 1 plus R to the T, right? So what's the present value of the stream of income that they've lost during the strike? Set that guy aside. We've got G, which is our gain from the strike or lockout. All right. So for our owners, this is maybe a decrease in salary that we have to pay, or maybe it's an increase in the number of years till free agency. For our players, these gains are going to be the exact opposite, an increase in salary, or perhaps a decrease in the number of years till free agency. Okay? And these gains are going to be won and received after the strike, right? So we're going to have G here equal to our summation, T equals 0 to T, GT, 1 plus R to the T. Finally, we've got F, right? And we're going to call this our fan repercussion. All right. So fans look at this and they say, okay, we're going to blame millionaire players and billionaire owners. Okay, so that can happen in lots of different ways, right? Maybe seeing fewer games. When you go to the games, paying less likely to buy concessions, less likely to pay to see games, can come in lots of kinds of different ways. So we have F here, summation T equals S to to T, right? And we have our fan repercussion, once again, just a present value of the stream of repercussions. Okay. So if we look at this, our winners of the strike are going to get A, their alternatives. They're going to lose M. They're going to gain G, and they're going to lose F. Okay? And they're going to do so with probability P. Our losers, they're going to get their alternatives. They're going to miss their M, all right? And they're going to miss F. They're not going to get G. And they're going to get that with probability 1 minus P. So if we look at this, we've got an expected value of our strike is equal to our probability P times our gains, A minus M plus G minus F plus the expected value that will be the loser, or strike that, the probability will be the loser, A minus, and I'm going to add these two guys together like this, okay? And when we simplify this guy, we'll take P times all these values, we'll take our 1 minus P times all these values, and we simplify, we're going to get the expected value of our strike is equal to the probability of our gains minus M plus A minus F. So if we look at this, the expected value of our strike, which is what this is the expected value of our gains minus the income you could have earned, right, playing, plus the other income you could have earned minus the cost of these fan repercussions, right? So interestingly enough, of course, we can plot this. Okay, so remember, here's our guy right there. Here's our probability of winning the strike or the lockout, whoever it is that you want to look at. Some probability 1.0, some probability 0, right? And what we see is we have the expected value of our strike doing something like this, right? Where if we have a 0 probability of winning the strike, what are we going to have? Well, we're going to lose M, and we get A, but we lose F. Okay, and let's make that guy a little larger. Okay, there's some probability here where, in essence, we're going to break even. Right? So let's think about this. If our probability of winning the strike is less than this guy right here, right? Let's assume this is 50%. If our probability of winning the strike is right here, 25%, what can we expect to earn? Right? A negative amount right here. If our probability of winning is greater than that, let's assume we'd say 60% of winning the strike, then our expected value is some positive dollar amount, right? And so it would make sense for us to strike, right? So there's some break-even probability of winning the strike, where below that it doesn't make sense for us to strike. Above that it does make sense for us to strike. And this value here depends upon essentially the size of our gains, our income that can be lost, our alternative income, and the size of our fan repercussions, right? So let's set our G here equal to, say, 500 million. We're going to set M equal to, say, 200 million. We're going to set A equal to 100 million. All right, and we're going to set F equal to 100 million. Okay? So let's look at the expected value of our strike when it's equal to 0. All right, that's when our probability of winning is equal to the probability here of our breaking even. So we have our expected value of our strike equal to PG minus M plus our A minus F. We want to set that guy equal to 0. So what we have here is our PG equal to M minus A minus F. Just move this guy to this side. Here we have M minus A minus F over G. Right? And when we plug in our numbers here, we have our M here is 200. We have our A is 100. We have our F is 100. We have our G at 500. We do all this, we're going to see that we have 200 over 500 equal to 40%, right? So if our chance of winning is less than 40%, it doesn't make sense for us to strike. If our chance of winning is greater than 40%, it makes sense for the firm or for the athletes to strike. Okay, so there may have been an interruption in this, so let's kind of go back and review here. So we had our expected value of the strike coming up to here, right? Here was our expected value of the strike and our probability of breaking even here. And what, for example, we said in this example it was, say, 50%, right? So if our probability of winning the strike is 25%, we're going to see we have a negative amount of what we can expect to gain. It doesn't make sense for us to strike, right? Here, for example, if it's 60%, we're going to have an expected value of our strike that's going to be positive. It makes sense for us to go ahead and strike, right? And so we looked at this from an example. Here we had, say, our G was, say, 500 million. Our M was 200 million. Our A was 100 million, and our F was basically 100 million, right? And so if we look at the expected value of our strike, it's going to be equal to 0. We want to know basically where this guy is, so we want the probability to be equal to this probability of breaking even, right? So the expected value of our strike is equal to PG minus M plus A minus F. Remember, that is from right here, where we had that earlier. And then if we move these guys to this side, and of course, now we have the probability of our probability times our gains equal to M minus this A minus F. And then, of course, we'll divide here through by G, which is what this is. Looks like a B, but it's a G, right? So that we have something that kind of looks like this, right? Here is our M, right? The amount of income that we could earn minus A, or strike that. M is the amount of income that we could have earned. A is the alternative income that we do earn if we strike. F is our fan repercussions, and G basically here is the size of our gains. And we see here that in this example, we have 40%, right? So what we said here in this example is that if our chance of winning is less than 40%, it doesn't make sense for us to strike. If it's greater than 40%, it makes sense for us to strike, right? So what happens when we have changes here in these values, right? So let's look at, say, G changing. All right, so here is our probability, right? We have some old expected value, right? And if our G increases, I mean, if you could think about it, the size of our gains is going up, it makes sense, right, that this whole curve is going to pivot. So we have our new expected value of our strike, right? So we can see that, hey, if our gains go up significantly, that increases the expected value of striking, right? It makes sense for us to strike more. What happens if M increases? So we can have this increase in M relative to A minus F. So here is our probability. All right. Our expected value of striking, let's say our old M, our expected value of striking at our new M, right? We're going to see that this whole function shifts down. Same thing here if A minus F goes up, right, relative to M. We're going to see the entire function shifting. So here is our probability. Here's our expected value striking with our old A minus F. Expected value of striking at our new one, A minus F prime, right? You see that this guy is basically going down, right? If you think about this, this makes lots of sense, right? For this guy right here, M, remember M is our alternative income that we could earn. There we go. Or strike that. It's the income lost due to our strike, right? So if the amount of income that we're losing to the strike is going up, we better make sure that we're going to win our strike, right? On the other hand, if the amount of income we can earn in our alternatives, minus these fan repercussions, goes up, right? In other words, if we're striking, we earn $30 million. If we don't strike and we're playing, we earn $31 million. Hey, I'm only out $1 million. Why not go ahead and strike, right? So we see the guy moving this way. And then, of course, we can see the exact same thing happening if we see changes in our interest rates, right? So if we see our interest rates changing, here's our probability of striking. Okay. And here is our expected value of our strike with some interest rate R. If we see an increase in the interest rate, R, what we're going to see is a change in the slope of the expected value of striking curve. Right? So interest rates have gone up. All right, let's think about what that means. Interest rates go up. Go back to these expected values. Right? This guy goes up. If this guy is relatively small, if R is relatively small, then these A's over time are relatively equal to each other. If R goes up, early A's are much larger than later A's, right? The value of the future A's is going down. So in essence, what that means is that our gains basically are going down. And we get something like this, right? Where here was our initial probability of breaking even. This could be any number that we wanted it to. Let's assume it was, say, 40%, like we had in our example. And now it goes to, say, 70%. Right? Here's our new break-even probability. Hey, if our probability of winning the strike is less than 70%, it doesn't make sense for us to strike. We don't strike. Right? We're only going to strike if our probability of winning the strike is greater than 70%. Right? Same thing here in these other ones, right? Our gains have gone up. Hey, here we are at our old one, say, once again, we'll just say 40%. The gains go up. Hey, our probability of winning the strike is only 20%. But that's okay, it still makes sense for us to strike because the increase in gains is so large, right? Or something like here, right? Here's our 40%. Hey, we have this increase in M, right? The amount of income that's been lost to the strike, right? Well now, hey, we need to make sure that we have a probability of winning the strike that's at least 50% before it makes sense to strike, right? Or our alternative incomes have gone up, right, relative to the size of the fan repercussions. So here, say 40%. Hey, our alternative incomes have gone up. Well, I can earn income playing ball, or I can earn income appearing on television, right? So my alternative income has gone up. It makes more sense for me to go ahead and strike because I'm not that worse off even if I don't lose the strike, right? My probability of breaking even is now at, say, 30%. Here's our new one, okay? Okay, so that should finish up our unit here on Play or Pay, and we will start on Unit 4 in the next video.